all right. I don't need that in your answer. Now, this is a sarcomere. It goes from Z line to Z line. It's made of actin, thin filaments, and myosin, thick filaments. And I would like for you to know that the Z line, the actin attaches to the Z line, and the myosin attaches to the actin. Right? That's draw and label a sarcomere. Now, with that in mind, let's take a look at how sodium is regulated. How sodium, not regulated, related, wrong word. How is sodium related to muscle cell contraction? Okay? Now, I'll put up question number 3 right here. It's a draw label sarcomere. We're done with question number 2. Okay? Ain't a bad drawing, really. Not for me. I put a baby in it. I think it's pretty good. Okay. Question number 2. Draw label sarcomere. Question number 3. Sodium. All right. Sodium is released when acetylcholine is released. Sodium causes a change in the potential difference of the muscle cell. Sodium causes a change in the potential difference of the muscle cell, okay? You know what potential difference is, the difference in charges inside the cell and outside the cell. So sodium comes in and depolarizes the muscle cell. So what do I need right here? Describe the role, how is sodium related to skeletal muscle cell? Sodium comes in due to the attachment of acetylcholine. That's what I want right here. And I'm going to leave that right here, underneath this sucker right here. So it's question number 3. We may just be able to split this apart, all right? Question number 3, how is sodium related? Sodium enters the cell after the attachment of acetylcholine. Sodium enters the cell after ACH attaches. All right? Now, sodium is a positive ion. Sodium changes the potential difference of the muscle cell. This causes the release of calcium. So sodium enters the cell and causes the release of calcium inside the muscle cell. We're going to stop it right there. I mean with this question right here. So sodium enters the cell after acetylcholine attaches. The change in the potential difference causes the release of calcium. This, and you put down this causes the release of calcium inside the muscle cell. Which are this. Release of calcium inside muscle cell. I can't help but put 2 little charges up there on calcium. You don't have to put the charges on calcium, you just write down calcium, it's fine. So now we have calcium released inside the muscle cell. Okay? That is what sodium does. Now, it really is tough for us not to have enough sodium in our body because of the sodium that is used as a preservative. We don't have a sodium storage, we just have a lot of sodium in our body. So because it's in foods that we eat. And sometimes we go ahead and salt our food anyway. I like a little salt, just a tad bit of salt. Not enough to change my blood pressure, not enough to change my blood volume, but I like a little salt. Sometimes, especially on a salad or some mess like that. So the sodium causes the release of calcium. Let's go to the next objective right here. Describe the role of calcium in skeletal muscle contractions, okay? Describe the role of calcium in skeletal muscle contraction, okay? Now, I should have left my sarcomere up here because I got to go back to that. I'm going to redraw my sarcomere right here. So we're on 1, 2, 3, 4. 1, 2, 3, 4. 4, okay, excuse me. It'll come back to 3. I should have just looked up here, but I didn't. Describe the role of calcium right here. 1, 2, 3, 4. Now I got to go back to my sarcomere. I go back to my sarcomere right here, right? Z line, thin filaments actin, myosin right here. Now that's the sarcomere. I'm going to label it because you can label it yourself. There's an attachment site between actin and myosin. Don't worry about writing anything down right here. We'll summarize it here in just a few seconds. There is an attachment site between actin and myosin. When this attachment site is exposed, the actin and myosin interact and the muscle contracts. Let me say that again. There is an attachment site between actin and myosin. When this attachment site is exposed, the muscle will contract. The only way to prevent the muscle from contracting is to block the attachment site. To block the attachment site, then the muscle can relax. Well, the role of calcium is to expose the attachment sites between actin and myosin. So for our answer right here, describe the role of calcium in skeletal muscle contraction. Calcium exposes the attachment sites between actin and myosin. That's your answer. Now, there are two filaments involved right here. Two filaments involved. One is called troponin, one is called tropomyosin. I just want you to list these right here. I'm not going to show you their relationship, their specific location, but these are my blocking proteins. So, calcium exposes the attachment site between actin and myosin. You got that down. I believe you. The two filaments involved are troponin and tropomyosin. I'll write those words for you. T-R-O-P-O-N-I-N, 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 and tropomyosin, T-R-O-P-O-M-Y-S-I-U-M. T-R-O-P-O-N-I-N, troponin, tropomyosin, T-R-O-P-O-M-Y-S-I-U-M. That writing sucks. But you have a stab at it anyway. Now, I should go back and put all this under question number 1. But I didn't. I split it up a little bit. And we don't have to go back and finish question number 1 again, right? Because we've got the answers right here about the attachment of the release of acetylcholine causes release of sodium. The change in sodium causes the change in potential difference, which causes release of calcium, which exposes the attachment site to actin and myosin, and the muscle contracts. Now, I should put on you, how does a muscle relax? So what? Bingo. You got a muscle contracted right there. You flex your biceps. How you going to relax it? Well, you got to stop the release of acetylcholine, which reabsorbs the calcium back into its storage vessels right there, because it's going to stop the influx of sodium to change the potential difference. And when you remove the calcium, the attachment sites are blocked and the muscle can relax. I don't have that on there. I don't have that on. For extra credit, if you want some extra credit, put that on there and I'll mention it one more time. How does a muscle cell relax? I don't see it on here. Okay, how does a muscle cell relax? It relaxes when the release of the neurotransmitter is stopped. Now this is for extra credit, write it down or not, it's up to you. Put it on there, making sure that I can see it. I'll give you some extra credit for it. How does a muscle cell relax? It relaxes when the release of acetylcholine is stopped, which causes the reabsorption of calcium, which let's see, I got to have something there about the troponin and tropomyosin, which allows troponin and tropomyosin to block the attachment sites between actin and myosin, and the muscle relaxes. Okay, let me see if I can't say that again. Maybe in the same words or same phrase anyway. So the muscle cell relaxes when the release of acetylcholine stops, the neurotransmitter stops, which causes the reabsorption of calcium back into its storage vessels inside the muscle cell right there, which allows troponin and tropomyosin to block the attachment sites between actin and myosin. That's it in a nutshell. If you want it, put it down. If you don't, that's all right too. All right? Now, rigor. Rigor. I like to watch a whodunit. I like NCIS and CIS Miami, whatever, a lot of the murder mystery shows right here. And one of the questions is always asked, how long has he been dead? When a victim is found, how long has he been dead? But if he has not gone into rigor, it's less than 6 hours. If he has gone into rigor, then it's 6 to 12 hours. Okay, rigor means stiff as a board. So continued muscle cell contraction is called rigor. Continued muscle cell contraction. You're already dead. You're already dead right here. Now, how does this relate to the role of ATP right here? Well, when the muscle contracts, ATP is needed for it to relax. When the muscle contracts, ATP is needed for the muscle to relax. That's part of your answer right there. When your body runs out of ATP, the muscle cannot detach. That means the actin and the myosin stay fixed together. So ATP is needed for the attachment of actin and myosin to break. Without the breakage, it stays contracted. When it stays contracted, you're in rigor. Okay? I hope you got that. Now, the two connections of skeletal muscle, we already did that. List the skeletal muscle connective tissue to describe the connection to the periosteum. We'll do this right here, and we may do another one right here, and then we'll take a short break. Okay? Now, for me to do this, I got to go back to that gross-looking muscle right there. I got to show you some parts of a muscle. So hang in here with me. We're on this is the skeletal muscle connective tissue. CT stands for connective tissue right here. So hang in here with me just a few seconds. All right? I can get rid of this right here. I can get rid of this right here because we're done with it. That's the toughest part of this whole blooming lecture. The toughest part of this is getting the muscle cell contraction. It really is. So let's go back to this right here. I'll give you the names of the connective tissue in just a few seconds. Okay? I don't remember the number. I don't have everything's numbered. Yeah, I got it numbered on this other one over here. No, I don't. 1, 2, 3, 4, 5, 6, 7. Let me put a 7 on there. If I brought a pen. I brought a pen and write that number 7. At least so I know where I am. This is skeletal muscle connective tissue describing the connection of the periosteum. All right. This will make sense to you in just a few seconds. Right here. Let me go back to this right here. All right. Origin and insertion right here. Skeletal muscle cells. I'm going to do a cross section right to the center of that muscle belly. That cross section right here shows me because the organization of skeletal muscle cells right here called fasciculuses. A fasciculus is a group of muscle cells. You can't see it when you look at the gross muscle. You can see it when you make a cross section across the muscle belly right there, and you got to put some stain on it right here, some iodine stain or some new methylene blue stain, and you can see these gross connections right here. So my muscle cells right here are grouped into fasciculuses. Fasciculus. Fasciculus is a group of muscle cells, or a group of cells. When we do this in a nerve, we've also found a fasciculus in a nerve. So it's